Hello and welcome to another SolidWorks how-to video. This video should be relatively quick. In this video, I just want to go over sort of one of the instances, one of the major examples of a time when we do an assembly, but we don't necessarily want everything to be completely mated and locked down, and times when we want things to move. So I'm going to start out by creating the parts that I'm going to use in this assembly, and I'm going to keep those fairly simple as well. So I'll hit OK on a new part. And I'm just going to, on the top plane, I'm going to feature extrude, and we're going to stick with circles for now. Circle, and at the origin, just draw a circle. At the origin, draw a circle. And what I'm looking for is I'm looking for basically a tube. So I'm going to smart dimension that first circle. I want it to be 1 inch. Now, what I can do here, rather than define, if what I care about is a wall thickness, I can select the inner circle and the outer circle and actually get the wall thickness defined. So I don't actually have to guess, or well, guess is, a strong word. I don't have to do the math in my head as to what kind of wall thickness I need to hit, say, 50 thousandths of an inch. I can just type it in as the wall thickness by selecting both circles and entering that dimension. So we'll leave it there, 1 inch diameter, 50 thousandths wall thickness. And what we're really looking for here, let's go 4 inches long, is this going to end up being the body of an air cylinder. And for now, I'm going to leave end caps off. We can certainly put those in if we want more detail, but for the purposes of this demonstration, this works just fine. So I'm going to go ahead and I'm going to save this as body. And then I'm going to create a new part for the cylinder rod. And in this case, on the front plane, I'm going to do a revolve because it should be a little faster. Let's do a revolved boss. First, I need a center line. We'll make that infinite length, and we'll make sure it is coincident with the origin. Now I'm going to go ahead and draw my cylinder rod with piston. So we'll start at the origin, come out here, come down a little, and we'll just make it a very, very simple cylinder rod. Here. Now our body was 4 inches, so we want the sort of extending part of the rod to be, a little longer than that. Let's go 5 inches. And just so that it sticks out when it's fully returned, we can give it a 1/4 inch for piston thickness, and let's go ahead and give it a 1/4 inch for rod diameter. So fairly weird proportions, but again, for the sake of sort of showing you how it works, this will work. So let's save that as rod. Now I'm going to bring those into an assembly. I'm going to create a new assembly. The first part I insert will be the body, so I click it from my little insertion menu, drop it in. And again, the first thing I want to do is I want to float it because I don't know where this part landed. I just kind of clicked it in space. So I'm going to float it. Then I'm going to select it. I'm going to mate. And now in my model window, I'm going to expand the tree here and just mate the origin of the body. First, I need to deselect. So clear mate selections. Select the origin and the origin. Oh, you are locked. Why are you locked? Cancel. Mate. We selected first. So mate. There we go. Origin. We need to not have that part selected first when we hit mate. So it automatically coincident, align axis, which is what we want. I'm going to accept it with the green check mark. I'll accept it again. Now, I would normally, stop this thing from rotating, but in this case, it doesn't really matter. Again, normally I would grab, say, the right plane here and the right plane of the assembly and mate those, which is just a click, one button click, right? I want them coincident. And now it's just locked down, right? My minus sign is gone. This thing can't rotate anymore. So now I can insert rod, and I will just drop that in, and that is nowhere near proportional. I must have messed up a diameter somewhere. So let's right click edit the part. I can edit it right in the assembly. Let's save the assembly. Call it cylinder. Yes, I know it's not mated yet, but we are now editing it so I can edit the sketch that goes with that revolve. Yes, that's okay. Oh, I didn't define the diameter at all. That's handy. Smart dimension, a 1-inch diameter because that was our cylinder bore. That would be why our proportions look a little off. So accept those changes to that part. Now is the time to mate. The first mate, and now I'm going to mate this in such a way that this cylinder rod can actually extend and retract. Very handy in a lot of cases in assemblies with parts like air cylinders that actually move. So the first mate, I'm going to hit mate, and I'm going to select the piston diameter, and I'm going to select the bore. Okay. And it automatically wants them to be concentric because when you select two diameters, that's sort of what SolidWorks assumes you want. The problem is, in my head, this rod should be pointing up. It's not a huge deal because we could always make it point down, right? It's symmetric in this model. But in order to get that flipped around the way that I had it pictured, over here in my mate properties, I have a mate alignment sort of toward the bottom. If I click that, it'll automatically flip that rod upside down, or at least reverse from what it assumed I wanted. So that's a quick way. I can go back and forth, but that's a quick way to sort of flip some of these mates around if SolidWorks brings it in a way that you don't think it should. So I'm going to go ahead and accept that with it flipped. And now I've got it concentric, so I can drag it up and down, but it'll never leave sort of the center line of that cylinder. So now, what do I do to make it so that it's, well, I could, I guess, leave it like this. Problem is, it's not going to stop at the end. Now, this air cylinder would typically, again, have end caps, right? I can't go back further than the body, and I can't extend further than the body. So what can I do to sort of block this from happening? Well, there's a couple of things. The simplest way, I'm going to bring this down so that it's at least in the body where I want it. The simplest way is an advanced mate. Right. And under advanced mates, I've got all kinds of fun things. Like, for instance, width comes up a lot. Width is a good mate when you need something to be exactly centered. So if I wanted this rod to be locked so that it's sort of in the middle always of the air cylinder body, I could select width, and it's going to want two faces, parallel faces, and two parallel faces from two different parts. So the first one, I would select the ends of the body. So that end face, that flat face, and I would select the other end, right? And notice the blue selection dropped, so it's happy, it changed. Now I'm going to select the faces of the piston. And notice it slid just a little bit, but if I go out so we can see the highlighting, the pink is the piston selection. And now if I accept it, that rod will be forever locked to the middle. That's what a width mate does. It locks it between two flat surfaces. So it'll be exactly centered. I don't really want that. I want it to be able to move. So I'm going to delete the width mate. Just delete. And now I can go back to sliding in and out, right? But again, I need it to stay in the body. So if I select mate, I've got some other choices. For instance, under advanced, if I select this is a distance mate. So if I select it, and right now, if I just select this face and the top of the body, 1 inch was in here. So if I look, I can actually prove it. So I will accept. If I select this and use my evaluate measurement and expand my little window here, they're 1 inch apart, right? Normal distance, center distance, 1 inch. So that mate, the distance mate, by default sets a distance. What I can do though, if I go in and select edit feature on the mate itself on the distance, if I under advanced, I have a min and a max here that I can set. So minimum, if I set that to 0, And I was 4 inches long on my body. This is where some math comes in when we use this mate type. I was 4 inches long on the body, a 1/4 inch tall on the piston, so 3.75 should be where we want. I'm going to accept this. Now, with a minimum of 0, that's saying that it can't go past 0, so it will stop. I'm dragging, and I can't get it to drag out of the cylinder anymore. Likewise, I told it the furthest away that it could be is 3.75. And notice it stops, and I'm dragging back and forth, and I can't go past the bottom. So the distance mate with a min and a max are perfect for this kind of application in getting an air cylinder that actually moves and follows the rules, that it doesn't try to blow through the parts that are on the end. So real quick, like I said, I promised it would be sort of quick and dirty. We can do the same thing with other mates, by the way. Assembly, mate. I'm just going to show some of the other types under advanced. We can do the same sort of thing with angles. If I have an angular mate, I can set a min and a max. If it's a joint, for instance, that rotates, I can do it that way. We also have some options, not so much in this case, but we have some options for the way things would move in in actual assembly. So there's cam mates. The slot mate is especially effective for when we need a pin to sort of follow a slot or a roller to follow a slot. But these are mates that allow these parts to actually move. I'm going to go ahead and get out while being fully constrained. So we may not, because, well, let's actually, the minus is there. Let's stop it from rotating, because again, I didn't lock it down. It's tough to tell in a round part, but you can actually, I'm rotating it as I drag my mouse sort of in this direction. So let's grab the right plane of our rod and the right plane of our assembly, and notice they're kind of at a, funny angles. If I mate those, and it's coincident, which is what I want, let's accept the mate. That'll stop it from rotating. And notice, even though I can still move the rod, the minus sign is gone because this is fully constrained. It's fully constrained, but it can still move. It's fully constrained because we have defined minimum and maximum sort of stroke in this case, but minimum and maximum distances from the end of the cylinder cap. So that is one way, and a pretty effective way to get pieces in your assemblies that can actually move somewhat true to life. And again, especially handy if part of the goal, if we're designing an entire machine here in SolidWorks and we need to see how things react when they move, this can be a very effective way to sort of get that done. So thank you for watching, and I look forward to seeing you in the future in another SolidWorks how-to video.